My name is Chris Beaumont, and this talk is on Glue, which is a kind of data exploration library that I started as kind of my thesis procrastination project in grad school, and is now my day job. So this has grown into something that NASA is currently funding. So I went to grad school for astronomy, and now I'm working for Harvard and NASA to kind of build this up to something that NASA will be using for their data sets. But more broadly, I kind of want to make the pitch that Glue itself as a tool might be useful for you in your data exploration, and also talk about this idea that I'm trying to articulate about kind of hackable user interfaces, this idea that maybe we need more tools that sit in between like command line or mainly code-driven programs and GUI programs for working with data. So I'll try to explore that a little bit as well. If you remember nothing else, just know that there's this project called Glue, and the website's glueviz.org. My Twitter handle is @BeaumontChris. I'll tweet out links to this after the talk. And also, if you just go to bit.ly/dataconglue, that's a link to a repository that has some of the notebooks that I'll be going over and links to Glue as well. I would recommend that you probably not try to download the full Mac binary application of Glue right now, just because if everybody tries to do that, we'll kind of crash everything, because there's not a lot of bandwidth. But I encourage you to kind of work through this whenever you want to. Anyways, so to kind of motivate this, this was a question that was on Quora maybe 2 weeks ago. Somebody asked, what is the future of data analysis? And Michael Horchester, who is the director of data science at LinkedIn, said that he doesn't think that the big breakthroughs are necessarily going to be all algorithmic breakthroughs, but instead he kind of said the biggest gains are going to come from tools that allow analysts and others to browse, query, summarize, filter, aggregate, disaggregate, and view their data interactively. And this really resonates with me. I mean, I come at this from maybe more of a scientific bias than a industry bias. But I've definitely felt this idea that like the bottleneck for discovery is really about being agile with data more so than having like really sophisticated data analysis techniques. Those things are important, but I spend a lot more time just like munging data and making kind of like quick explorations of data than I do really heavy duty analysis. So kind of I think the scientific phrasing of that same statement is, we have this, like if you Google the scientific method, you get a bunch of images that look like this, that you start with a theory, you make a prediction, and you gather some data that you think will kind of relate to that prediction. You do some analysis on that data, you run an experiment, and then that kind of tells you something about the theory. The problem is I've never actually seen science work like this before, and instead, I think the picture looks something more like this. So it's much more organic, and I've still drawn these little like circles of asking a question and then running a little experiment to see if kind of the data are consistent with your expectation. But I think they're much tinier cycles, and the questions you have aren't grand questions about the universe, but they're things like, are my data calibrated properly, or are these two quantities correlated like I expect they might be? And you just do this like hundreds of times during any kind of research project. And it's really, there's a lot of dead ends in that process. You ask questions that you think might be interesting, and you almost immediately recognize that like there's not enough signal in the data, or it turns out that the data obviously kind of preclude that idea. It's hard to predict what things are going to be dead ends before you actually do it. You just kind of have to go down this path and continuously iterate on these kind of questions and play with your data in a bunch of different ways, kind of walk around in the data like Alan Downey said this morning. And then eventually you kind of like iterate towards greater understanding about whatever you're studying. So I think both, like this diagram and the Quora question are getting at this idea that being able to kind of slice and dice data very easily is really important for understanding data sets. And I think, especially in science, we live with this kind of uncomfortable dichotomy between the interfaces that we use to do data analysis. On the one hand, we have mainly code-driven interfaces, and so like I'm a big Python guy, so I use IPython and the Python libraries a lot. These are really great. I mean, like their strong points is that code is incredibly expressive, right? So anything that you can kind of think up, it's possible to translate into code and then run it, and that's kind of amazing. Because you have to translate your thoughts into something a computer can run, it's much more reproducible and precise. You have this kind of like unambiguous phrasing of your intent. It might not always be what you want it to do. There's bugs in codes and stuff. But it's pretty easy to kind of like rerun code that you wrote down once, so that's nice. And it's like automatically scalable, right? So if you do anything in code once, it's very easy to put that in a loop and do it for 100 data sets or something like that in a batch script. So that's all great. The problem with code-based data exploration is that it's relatively slow and it's harder than working with a GUI. I mean, you do have to translate your kind of scientific questions into some sort of syntax in a programming language. And I haven't met anybody that's able to kind of like both write code and think interesting questions about data at the same time. There's always like a context switch that happens where you have a question and then you kind of have to switch modes and say, I'm going to write some code for a while now, and then you run the code and then you kind of switch back. There's like friction there associated with that. On the other hand, we have GUIs, and so we have things in astronomy for working with like images, for example, that are a lot easier than kind of making static images with matplotlib. Kind of in more industry settings, there's tools like Tableau that let you kind of like work with tabular data really easily, or even things like Excel or Google Spreadsheets or Plotly. Compared to code, those are nice because good interfaces tend to be a lot more intuitive than writing code, and so it is actually possible, I think, to stay in that high-level creative thinking about data when you're working with GUIs. It's also much less sequential, so you know, if it really is true that working with data is this kind of like organic, branchy process, it's kind of hard to like branch your thought process when you're writing code, especially in like imperative languages like R or Python. But with a GUI, it really supports a lot of like kind of nonlinear exploration, which is great. And it tends to be really fast for the things that the GUI was designed to do. The downside of GUIs is they tend to be canned, so there's a framework for doing something really well. But if you want to do something that the GUI wasn't designed to do, usually that's really awkward and cumbersome. And they're usually less precise because you don't have to translate your thoughts into computer code. Some things are very natural to do, kind of organic selection type things. But if you need to express some very specific intent, usually GUIs start to get in your way at that point. So if you're kind of trying to like fill out forms sometimes, just like having to kind of like use a drop-down menu to enter in a number, like a lot of times it's just easier to write out code that kind of does that for you. And the really frustrating thing is that, okay, so we have these two things. They're kind of complementary to each other. Neither one, I would argue, is really ideal for the entire life cycle of data analysis. But the problem is that moving in between these things is really uncomfortable. And so we almost have this kind of like valley of sorrow in between these interfaces. And if I start in a GUI and I get to the edge of what the GUI can do and then I want to move into code, I have to do a lot of repeated effort. It's usually really hard to kind of like save the state of the GUI and then like immediately jump into it from code. I usually have to kind of like redo whatever I did in the GUI in a code, and that's kind of awkward to do. And so that's kind of frustrating. And in fact, it's so frustrating that I've met a lot of scientists that just avoid crossing the barrier entirely. They either only work with code because GUIs are they're not reproducible enough, they can't do everything. So they just do code for everything, or people that just only use GUIs and they never learn how to code. And I think both of those things are not ideal. And so that was kind of in my mind when I was in graduate school. I was using GUIs and code a lot, and I wanted better ways of moving in between them. That was one of the main motivations for Glue. One of the other main motivations is that I was doing a lot of comparisons between different files. So I think as we get richer data sets, the relationships among data sets kind of become more interesting. And in astronomy, for example, like I'm always comparing multiple images of similar regions of the sky, or I'll have catalogs of objects in some region of the sky, and I want to overplot those on images. And that was always a really painful process. And just to illustrate this, this is, how many people have used the Worldwide Telescope? It's a Microsoft research product. It's really cool. So it's kind of like Google Earth, but it's aggregated a lot of astronomical images, and it makes this really nice kind of zoomable interface where you can kind of just, go into this one nebula and see Hubble images on top of a whole bunch of other images, which is really cool. And then if you zoom out, it actually has like all this catalog data about our kind of what we know currently about the universe. And so you have this kind of 3D flyable model of the universe, which is really cool. It's been downloaded, I think, tens of millions of times. But it was kind of interesting. I mean, like after this product launched and people had used it a lot, somebody at Harvard was looking at their kind of model of the universe, and they were trying to overlay one of their own data sets in this tool. And they realized that the entire universe was kind of like flipped inside out and backwards because they messed up some coordinate transformation when they kind of stitched all this data together. And I do this constantly, like when I was in grad school, like kind of aligning data sets is something I never get right the first time. And it's just really obnoxious. If you saw the Apple Watch announcement video last week, the guy was talking about how like there's a mode in the watch that will let you kind of like tap on your watch and see the solar system in its current position. I promise you there's an upside down planet somewhere in that app yet, and they just haven't found it yet. Like it's just something that happens, and it's really obnoxious. And so I also wanted something that would kind of make that process of kind of intercomparing data sets a lot easier without having to munch things together. So I kind of just already said this, I wanted something that was kind of felt like a GUI that would let me make visualizations of related data sets pretty easy. I really like this idea of linked views, which I'll show you in a second. I wanted something that understood images because that was really important to me, and something that was kind of hackable. So it wasn't just a GUI, but something that allowed me to kind of like write code that somehow attaches into the GUI. So let me just try and kind of illustrate what I mean by all this by showing you glue. This is always dangerous, but I'll try a live demo. So I'm starting the interface now, and this little Python script here is just loading up 2 data sets so that I don't have to do that in front of you. And once I get the interface here, I'll see the 2 data sets over here. I'm just going to relabel them. One is an image, so I'll call it image. The second one is a catalog of objects, so I'll call it catalog. And the idea is, so Glue is a Python program. The most basic thing it is kind of this interactive layer on top of matplotlib. So it makes it easier to make standard matplotlib plots. So for example, if I take this image and I drag it into this visualization area, it asks me how I want to view the data. I'll say image viewer, which is its default. Try to get rid of this keynote thing, which I cannot do. Okay. And so, okay, so I get an image of this. This is like a star-forming region here. It's not super important physically. And so, I can zoom into the image, and we've added some extra kind of interactive buttons on top of the standard matplotlib stuff, so you can adjust contrast, things like that are useful for astronomers. But you can also make kind of multiple views into the data. So if I drag this over again, I might want to plot like the distribution of pixel intensity values. So I'll make a histogram of this data set now. And that's that, and there's too many bars here, so let me just kind of like change the number of bars on the x-axis, so I can kind of configure the plots using these windows over on the left. And so now I have a second view into the data. And these things are always connected, so that if I want to select some region in some plot, say like I care about this range of the histogram, that corresponds to a particular range of pixel brightnesses, right? And so if I make that selection, I see kind of the selected regions displayed in both representations of the data, which is kind of nice. And I can go the other way too. So if I like care about this particular part of the cloud, I can drag that over there, and maybe I want to independently normalize these things. And so I can kind of like compare the brightness distribution in the left part of the cloud versus something else. But what else I can do is I can take the second data set, which is a catalog, and I'll make like a scatter plot of it now. And you can see actually that there's already points that are highlighted here. So somehow it's taken my selection in this image and kind of figured out how to take that selection in one data set and apply it to another data set. Let me just kind of make another kind of selection over here. So this is useful kind of set of quantities to plot in astronomy. It's called a color plot. The main point is that there's some diagnostic value into like picking out things in the upper right corner of this plot. So like these things here tend to be stars that are like very young in the process of forming. They're very red. So I could take these green points. Let me delete the red points for now. And if I want to see where these green points are relative to the gas in the image, I could just highlight the selection here and drag it, and drag it on top of the image. And it puts those points, I don't know if you can see that, well, you can see it a little bit. And so it figured out where to put these points in the image. And again, it's still live, so that if I want to select all of the points in the catalog that are in this box, I just make a selection over here. And I can see this kind of cloud of points. I can also toggle different layers of visualization. So if I want to not look at the highlighted pixels, but just the highlighted points, I can do that as well. So the question is, how does it know how to do that? How did it figure out how to kind of like take a selection in one data set and go to another? One of the things that the startup script did is it defined some links, what we call links in Glue between data. So if I open up this dialog, these are the 2 data sets that I've loaded, and these entries in these lists are all the different attributes that are associated with the data. And in this particular case, both data sets have a quantity called right ascension, which is like longitude for astronomy. And these are the same quantity. And so in my startup script, I've actually said these things are identical properties. And that's what this link over here says, that right ascension is mapped onto right ascension. And likewise, there's declination in both data sets. That's like latitude. And so once I kind of inform Glue that these things are the same quantity, it has enough information. It kind of knows what quantities are being plotted on each axis of a visualization. And so when you draw something out, it kind of knows a little bit about what that selection means in a coordinate space. And if it needs to, it can kind of like do data transformations on the fly to apply a region drawn in one data set to filter rows in a catalog in another data set. This is a really simple linking. It's a like identity mapping, like a one-to-one mapping. There's a lot of other kinds of links that you can define. So like one common thing is you might have coordinates in 2 different coordinate systems that are kind of rotated with respect to one another. And in Glue, you can actually provide your own coordinate transformation functions that kind of take arrays as input and return arrays as output. And I can say, like this is the function that would map like these 2 quantities in this data set onto these 2 quantities in another data set. And if I just kind of like set up that mapping, Glue will figure out what kind of series of transformations to apply in what order to kind of like do the right thing. So that's kind of like Glue in a nutshell. It's worth noting that the linking that I showed was pretty basic, that it was the spatial linking, and that's very common in astronomy. But the notion of linking in glue is meant to be very flexible, and it doesn't have to be kind of like a one-to-one linking or even a spatial linking. So here's another example where this particular like weird tree diagram is something we do in astronomy, where we take images like this and we kind of abstract them into these like nested structures, and then we represent the nested structures in the image as nested structures in a tree. And so there's kind of this like non-obvious mapping between collections of structures in this tree and collections of pixels in the image, and there's a lookup table behind the scenes that's kind of performing that transformation. Glue is able of kind of like understanding a lot of links like that too. So if you select parts of regions in this scatter plot which map onto these structures or particular structures or whatever, like it propagates things across. Like if there's a logical link that you've set up between these things, Glue will just kind of do the right thing, which is kind of nice. So that helped with a lot of the kind of data munching, frustrations I was having in graduate school. Some other things that were nice. I talked about wanting something that would make the transition between GUIs and code a little bit easier. One of the first things we did is, in astronomy, one really common thing to do is to use a series of like Python scripts or some kind of scripts to start with raw data and then like reduce it somehow or clean it up. So maybe we calibrate things or we subtract out background signals or something like that. And then we'll use interactive tools to look at the results of that reduction pipeline to see, did it work correctly? And then we'll, like after the tools are open for a while, we might identify some sort of quality issue. So then we go back to our reduction scripts, we tweak them, we rerun them, we remake new reduced data products, we reopen the tool, we get it back to the state it was before, we check to see if we fixed the problem or not. And there was a lot of, like pain in that cycle. And so one of the things we added to Glue was the ability, if you've loaded a file in Glue, you can set it up so that it watches to see if that file ever changes. And if it does, it kind of reloads the data and then sends it into the plot without you having to close down Glue. So this movie here is just showing it's made up data, but it's made up data that's being rewritten every 3 seconds or something. And so we've just kind of like loaded up a couple of different viewers in Glue, and without having to close the program, we can kind of see the data update in real time. So if you had like data that was streaming or it's kind of updating on a regular interval, if you want to tweak some sort of reduction pipeline, as long as your reduction pipeline is producing files at the end, you can kind of do whatever kind of pre-computation you want, which is kind of nice. Another nice thing is because Glue is written in Python, integrating with things like IPython is really kind of easy. And so there's a lot of nice ways of doing that. So just to illustrate this is a table of FBI crime statistics. So you can kind of see like every year and state pair has basically crime rates per 100,000 people in a bunch of different crime categories. And so just from the IPython notebook, Glue has this function called QGlue, which will take common Python data structures like data frames or arrays or whatever, and just throw it into the interface. And so if I run this now, I'll be able to just play around with this data inside Glue. And so like one particularly interesting plot is if you plot year versus murder rate, there's one obvious outlier. These points are a little bright. Let me make these darker so you can see them in the back. Okay, it's a little bit darker. So there's all these points up here, and like Glue makes it really easy to isolate outliers, right? So we'll just select these points first. And then we might want to make a second plot to say like, yeah, well, what are these things? So if I make another scatter plot, I obviously know the answer already at this point. If I plot state versus murder rate, I can see all these red points are in one state. And if I hover over what that state is in this plot, it says the District of Columbia. So it's somewhat kind of not a fair comparison that you're comparing one urban area to a bunch of other states. But it is true that in the 90s, there's this huge spike in murder in DC because of cocaine, actually. And you can kind of pull that out pretty quickly in Glue. But the main reason I pulled this up is I wanted to show that when you're running Glue from the IPython notebook, it doesn't actually block, and it returns a data structure that is kind of like synced up to the state of Glue. And we try to make that data structure very shallow, meaning like you shouldn't have to learn like a really complicated Glue API to be able to kind of like mess around with the data. So we try to keep it simple with things like NumPy arrays or whatever that you might be used to. So if I print out the data collection that's returned from that thing, it's like a list-like object that has one item in this list, one data set called states. So if I look at that first item, I can see all the different attributes in that data set. So there's the murder rate, the rape rate, the robbery rate. So these are basically the columns of that data frame. But if I kind of like that data object's like a dictionary, so if I just say, like, give me the murder rate, it just gives me a normal NumPy array. And so I can kind of quickly get data out of Glue and run, like play around with it in the IPython notebook. And so, for example, one thing I might want to do is like import scikit-learn and then do something in IPython that's kind of hard to do in the GUI. So this is just running like a k-means cluster analysis to divide the data set up into 3 clusters. And the clustering is based on looking at the robbery rate, the rape rate, and the murder rate. And then it's saying, like, once I have those clusters, let me send those back into Glue here So I'll take the 3 clusters and kind of assign them 3 different colors. So if I run this cell, it's now done. And if I go back over here, I see I have 3 new clusters. And so I'll delete the old thing that I had. And now I can kind of like quickly play around to see like, well, where are these clusters? And I could just, like if I look at murder versus maybe assault, and I just like kind of pen through these things, hopefully at some point I'll start to see like a dividing line between these things. I think it's usually like the robbery rate. The colors are a little bit hard to see, but you can kind of see a dividing line here. Is there a question in the front? Oh, so how did I mean, so I just have 2 windows open right now. The question of how am I allowed to run glue and IPython at the same time? Yeah, so sorry, I might have kind of breezed through that. But what I did up here is I started glue from IPython, which popped up a second window. And so now I have 2 things going on in parallel. And so they're both basically communicating with the same data right now. How that works? Mm-hmm. Yeah, so that Q glue is the function that starts up glue from IPython. So that's kind of the magic there. Yeah. Another thing that's worth noting is, again, like the thing that's really easy in glue is like picking like weird clumps of outliers that are really hard to define programmatically. So it's like, here's a circle of things that's now in orange. It's always a pain to define selections like that in code. And so you can also get access to the subsets that you've defined in glue. I'll skip over this thing, but if I just look at basically like the first subset in the data, it's called subset 5, and that's what I call it over here. If I just change this, so I'm not cheating, like hi there, and I run this again, now the subset is called hi there. The cool thing is if it has like a toMask function, right, that turns the subset into a NumPy Boolean array, and that's cool because a Boolean array you can use in Python to select out rows in a data frame. So if I just want to look at those particular things that I selected, I can convert the object to a data frame and then use that subset mask to say, like, here are the first couple rows of those points that I selected. And so you can kind of like hop back and forth, maybe a little bit more easily than you could otherwise. And that's kind of impossible in part because we've tried to keep the, like the internal data structures in glue, like really boring NumPy pandas things. Yeah, another question?
So within glue, when you selected those fibers, that high layer curve, what is the scripting at backend? Inside glue means what it was doing. If I want to extract that for my...
Yeah, so if you want to extract the things out. So when you make a selection in glue, what it saves is actually like a description of the geometrical thing that you drew. And it also saves basically what attributes were on the axes when you do that thing. So it's kind of saving all the metadata needed to apply that to something else. And there's a lot of ways of getting that out. So the easiest way, if you're in the IPython notebook, if you just call this toMask function, you now have a data structure that's a Boolean mask. We also have a thing in glue that allows you to save data sets out, which will just be kind of like 1-0 files.
Okay, so that would be like I've subsetted the data.
Yep. And it'll be a file that's the same shape as your original file, but it'll just be like in, ones like true, false, true, false, true, things like that. Okay, I want to jump ahead because there's some other cool stuff that I want to focus on that's brand new. Well, yeah, it's worth noting, like one of the really big pain points I always have with working with GUIs is getting data into them because they're this like black box, right? And so if the GUI doesn't understand the format of data you've written out, which it never does, you have to like iterate and kind of like find some sort of version of the file that your tool will ingest. And so we made it easy in Glue to kind of like plug in your own data parsers. And so if you have a function, a Python function that takes a path to a file as input and returns basically like a data frame as output, you can use that within Glue to load up any kind of thing. And so it's very easy because there's a library for everything in Python. Like we get some MRI data, we just Google Python MRI file loader. And then we kind of wrap up that library into a little function. Then we can load MRI cubes into it and work with things like that. And you saw the FBI data. We've looked with like GIS data. So it's pretty flexible for kind of getting data into Glue because you have some control over how that works. Okay, the last thing I want to talk about with how much time do I have left? Maybe 10 minutes or so. Well, is this idea of user-defined viewers. So this is something that's brand new. This was committed this week, but I think has the potential to become like the kind of cool killer feature in Glue. So to motivate this is one of the coolest data sets I've seen recently. There's this guy that made this clone of a level in Mario, and he brought it to a game conference and had like 1,000 people play it, and then just recorded all those plays. And so then he made this movie of all those things just happening at the same time. And it's just this amazing like massacre of Marios. Like you see them fall off of every platform you can think of. There's all these like weird quirks about, like the different paths people choose to take. There's some regions where everybody's doing the exact same thing. There's other regions where people are doing a whole bunch of different stuff. It's just like a really cool data set. And so it turns out that the guy who made this works at a company called stabyourself.net. And I sent him an email. I said, like, is this data available anywhere? Like, can I play around with this? And he said, yeah, sure. Like, here it is. So he gave me this big zip file of all this stuff. I think it's really cool that he kind of like released that data. And so it's this big, like catalog of basically timestamps and Mario positions for all these different Marios. And so I thought, like, man, this is worth playing with. So let me just kind of jump into a notebook I have prepared for that. So, okay, so here's another notebook. Let me make this a little bit bigger. Okay, and so this is a little bit canned, but just kind of like summarize what I do when I work with new data sets. We've seen talks that talk about this already. So this is loading, this cell just loaded the data set. I'm looking at the first couple rows. I see there's maybe like 5 or 6 dimensions. There's a run ID, there's a timestamp, position of Mario, the direction he's running, the animation state is like, is he standing still, is he jumping, is he sliding? And then the final time, which is how long did it take this particular player to finish the entire level. The describe function tells me how many observations there are. There's about 100,000 things in here. I might do something like, make a histogram of the final time. So this is the distribution of how long it takes people to finish a level. So most people are finishing in around 90 seconds. People go as slow as 3 minutes. Somebody finishes as fast as 45 seconds. This is a scatter plot of just all the positions. In some region, it's a very long, skinny level, but this is like one particular region. And I can see, people are running along things. This doesn't give me a lot of information because it's the static plot. I don't have a lot of flexibility to slice and dice this plot. But, I keep on going. So like here, I might want to munge the data, right? And like, instead of having all these observations be rows, I might want to kind of organize each run ID by a particular row. So I can kind of see the evolution of somebody's position over time just by looking at a particular row. I'll come back to that later. I also have the background image for the level. So here's one slice of that level, kind of showing of part of what that looks like. And then I might say, all right, so maybe I want to like scatter plot the points on top of this. This is kind of just like standard IPython stuff, right? So here are now the points on top of the image background, and I have a little bit more context, right? Like I understand now like why there's gaps in that upper plot because there's like a pipe in the way and people have to jump over the pipe. But I still don't have a lot of, like context about like what any individual person is doing, for example. So then I keep on going. And so the next thing that I do is I kind of like package up some of these like pieces of visualizations into some more functions. And I made this explore function, the gist of which is you give it a run ID and a timestamp, and it shows you the image level in the background. It overplots the particular run in red, and then it shows the location of that player at that timestamp as this black circle. And if you've used IPython, you probably anticipate where I'm going with this. IPython has this really great feature that if you have a function that makes a plot and it has inputs, you can very easily make widgets that attach to those inputs. And so it's called the interact function in IPython. And so if I run that, it does it again, but now I can take run and treat it as kind of like the scrubbable parameter, which is really slick, right? So now I can kind of just like pan through a bunch of different runs and kind of like get a sense of what the variety of data looks like, and I can kind of scrub forwards and backwards in time. Like, I just think this is like really nice. And it's still, there's other questions I have of the data set, but for the amount of effort that it took to get widgets on top of this, like this is clearly a really nice interface. And you see this also in tools like ggviz or Shiny and R, like the idea of allowing people to build up simple interfaces for playing with their data, but don't make them like, actually write user interface code, because that's really obnoxious. So I was really inspired by this, and I wanted to kind of bring this idea into Glue. To kind of use what Glue is good at, namely like selection and composing different views, and allowing people to kind of like make customized viewers. And so the idea is I've written some boilerplate code here. I've imported this new function called custom viewer. And when I create the custom viewer, I'm giving it a name called Mario. I'm kind of specifying the adjustable parameters. So the run and time are the same things that IPython is using. So I'm saying like run is some sort of adjustable parameter between 0 and 110. Time is something that I can adjust between 0 and 350. And then there's these 2 other pieces of metadata, which I won't go into, but they're needed for Glue. This is all documented. The idea is that, okay, so once I have this thing, there are different kind of functions that I can attach custom logic to. And in particular, Glue lets you implement a setup function, a settings change function, and a plot subset function. And so the setup, basically, like I'm just going to go and copy and paste the function that I use for IPython, right? So this show image function, I probably just want to draw this once at setup time in Glue. So I'm just going to copy this here. Then I have this draw timelines, which draws the red line and the black dot. So I'm going to copy this. And I want to redraw that whenever somebody kind of like messes with the widgets, right? So every time the settings change, I'll do that. And then there's one last one, which is if I select a subset in Glue somewhere, what do I do there? And I have this function here called draw points, which is just another normal matplotlib thing that calls the matplotlib plot function to plot things as scatter points. It's also using this kind of style variable, which Glue passes into functions to say, like, these points should be drawn as red. And you can use that if you want, or you can ignore it. This function does use it, so it kind of syncs up the opacity and the size of points. Okay, so I've just copied and pasted these three functions that I kind of debugged and developed in IPython. This should be enough if I did everything right. So if I now make a new Glue viewer with the same data set, I have the data, and now if I want to make a visualization of it, I see I have an option called Mario. And so if I open that up, I now have the same visualization as before. I can kind of zoom into it. I can pan around to new regions that I couldn't see in IPython, which is kind of nice. So I can go look at the end of the level. I can do all the stuff I did before, right? I can kind of like scrub around and look at the different runs. It's a little bit faster here because we don't have as much overhead with kind of serializing data and putting it into the browser, which is kind of nice. I can kind of like look at this dot evolve over time, which is kind of cool. But I think the really cool thing, if I kind of get back over to the same region we were looking at before, is I still have the rest of Glue. And so in particular, I can make like a histogram, right? And I can look at the distribution of final times. And so this is that same distribution I saw before. And I might be interested in like, show me like the really slow people. So I'm just going to like highlight some of the worst final times. And those get drawn on top of the plot automatically because I kind of defined what happens when I have a subset. And then I might want to compare that to like the fastest people, right? So let me make a new subset and highlight the really fast people down here. And now I can kind of just very quickly start to see things that I didn't see before. So like, for example, the slow people are basically exploring the full state of possible runs through Mario, right? They're just like exploring a lot of stuff. They're falling off of everything, right? The fast people in green are much more coherent as a group. And like one of the interesting things that I don't think is really obvious is that all of the fast people are taking this upper sequence of platforms over this. And this is kind of like almost like hive wisdom or like crowd wisdom, right? Like it's unlikely that any particular person playing this level knew that the upper sequence of platforms was faster than the lower sequence. But just by virtue of the fact that they were fastest, they couldn't have taken a slow path, right? So we've kind of like filtered out and learned something that these players individually didn't know, which is kind of cool. I want to just show one more demo kind of riffing on this. Let's see. So this is the same thing, but I've added one extra function in kind of like the long-term viewer for the Mario viewer, which also kind of defines what do we do when you make a selection, which allows you to kind of take the Mario viewer and actually select points in it, which is pretty cool. So I'll make the Mario plot again. I'll zoom into a particular region, and you'll see now, let's see, if I get back to the same series of platforms, I now have the kind of like selection buttons here. So if I want to select, like, just show me all the people who went over this upper platform, those are all the points. And then I could look, for example, make that same histogram as before of final time and look at, so those people are kind of like evenly distributed around all the run times. But then if I make a selection down here, people that go down the lower platform, I see, you don't see people that are like finishing really quickly. And I can even kind of like play around with the kinds of selections. So like if I toggle this check button here, this is a new Boolean variable that I'm passing into all my functions. And what this is doing is said like, and instead of just selecting the points that fall inside this box, maybe I want to select all the points along a particular run that pass through the selection I made. And so now if I kind of just say like, show me all the people that ended up above the end of the level here, I see all these kind of pass through that box. And Glue also has, kind of utilities for kind of like drilling down into selections using Boolean logic. So like if I select this button here, instead of defining a completely new selection, I'm going to take the intersection of what I've already selected and what I select again. So I've already looked at all the people that are going above the level, and maybe I'm also interested in all the people that also fell off a platform down here, right? So I just draw another box, and now I'm kind of like further filtering down into particular, very precise regions of phase space kind of quickly, which is kind of a nice feature to have. And so I think this is really nice because one of the like struggles I had when I was first starting out with Glue is it takes a lot of effort to build up like a fully fledged widget that like has all these like custom designed buttons. And we really had to make sure when we were making those widgets, like the scatterplot widget or the histogram widget, that they would make sense for almost every data set, right? And like almost certainly this Mario viewer makes sense for no other data set besides this one. Like it's hard coding the background image, it's doing all this stuff that don't make any sense for anything else. But it almost doesn't matter because it's so easy to kind of like prototype these things out and plug them in that there's not a lot of sunk cost into developing little widgets that work really well for one data set. And so you can kind of build these things and then throw them away when you're done, or maybe build them and iterate them and then kind of they slowly evolve into something that's more generic. And so I think this is a nice potential way of kind of using kind of the best of both worlds. Like you can write your static matplotlib scripts, but once you have them, you can kind of plug them into Glue and take advantage of its ability to select things. I think one more slide. Oh yeah, so this again is like brand new, but we've already like it's pretty easy to play around and make new things. And so this map on the bottom, somebody was using Matplotlib's base map toolkit, which draws maps and stuff, and he was looking at earthquake data, which is shown along here. This image on the top is like an NBA shot chart, so it's showing the kind of a heat map in the background of where people take shots in basketball. I don't know anything about basketball, so I might sound stupid. And then you can select based on different people, and so like this guy. Manu Ginobili, maybe, tends to take like a lot of points, the shots right outside the free throw line, and other people like are really close to the net. It's kind of cool. I don't know. And so, anyways, like it's really fun to play around with these things once you can make them interactive pretty easily. So I think like where I'm getting excited about, I think, and where maybe we can go with tools in the future is something like this, where we have things that are traditionally code-based, we have things that are traditionally GUI-based, and I think we should think about, like what can we build that's inside the middle? And I kind of, have this idea of like the term hackable user interface, something that combines aspects of both. Glue is one particular exploration of that idea. There's other ways that you could take this, and I think things like Shiny apps in R and ggviz are also going along this direction. I think it's worth thinking about, what are the kinds of things, like the thing that Glue does that's really nice is, it has a good interface for doing selection and layering different kind of visualizations on top of each other. That's only one kind of thing that you might want to do that's a more kind of like sophisticated thing. There's a lot of cool like grouping or faceting operations that you might want to map on to particular interfaces. I think we need to build tools that support these kind of like higher level, more sophisticated data munging tasks, but then build them in a way that we can use them kind of like programming libraries. We can kind of like rip them apart and recompose them into our own Frankenstein tools without having these very rigid kind of traditional GUI infrastructures. So I think I'll stop there. Glue is at glueviz.org, and I'm Beaumont Chris. Thanks again. Yeah, question?
So does the IPython notebook need to be running locally in order for it to plug into Glue?
That is a good question. No, it should be possible to have Glue connect to a remotely running kernel. Glue definitely has to be running on your local machine. And you might have to play around to actually establish that connection. It might not be well exposed. But basically, Glue is using the same mechanism of attaching to running IPython kernels. So there's nothing that's stopping that from happening. So, yeah.
Just to think in terms of reproducibility,
Mm-hmm.
so if I decide to run an analysis in Glue, then how would I package it so that it's reproducible by my colleague or?
Yeah, so there's two answers to that question. So one of the things that we've added in that works decently well is the state of Glue is savable. So if you make a particular configuration of plots, you can save that into this like JSON document, and then if you rerun that thing, it should reconstruct all the plots and all the subsets. That partially gets at that. The way we want to take that in the future is instead of kind of exporting to this opaque JSON document, we want to export to basically like a script template that would say like, here's the sequence that you would run in Glue to do the same thing. So that you could actually read the document and say like, like I did this, but now I want to change the code a little bit to do something else. That is a harder problem, and so it's something that we're working on now. But
That would be Glue script or that would be Python?
it would be a Python script. It might be using like a Glue API, right? Because Glue is a Python library, and so you'd probably make Glue-specific calls. The really cool thing would be have it export to something that never invokes Glue. It just makes like matplotlib scatterplot calls. We tried to do that at one point, and it was really, really hard. So I don't know. Yeah.
Can you brush millions of data points at once?
Yeah, the question is like, how well does this work with large data sets? The answer is not very well. Usually the bottleneck is matplotlib. So matplotlib starts getting really cumbersome for like scatterplots, for example, around 1 million points. And we're also doing a lot of stuff with in-memory data structures. So, like one of the nice things is that we're using a lot of normal Python data structures, which makes it more hackable. The downside is everything's in memory. And so you have to have enough RAM to load all the data that you want to work with in most cases. So that's kind of a liability as well.
How can we use this for geospatial, like mapping and
Mm-hmm. Yeah, you could. I think that you could definitely flesh out some of the interfaces for overlaying map data, for example. We've made little prototype things that do this in different. So you saw this like base map thing that's using Maplab's base map to plot things. I've also done things where I basically treat. So I load in like JPEGs of maps basically, and use the same kind of like image to catalog linking that I do in astronomy to kind of like map coordinates in like latitude, longitude into like particular catalog points. So that works. The thing that'd be really cool is to implement something like Slippy maps, right? So that you have like OpenStreetMap or something that you can zoom into. There's nothing impossible about that. It's just nobody's built that yet. It'd be cool. So, yep. Thanks.